All right, this is the fourth problem or the last problem on that first page, and we have a force that's actually acting at an angle. So the only caveat here is we're going to have x and y components of that force. So let's go ahead and label our forces like we normally do. So we're going to have mg going downward. From the surface, we have our normal force. And then I see this mu equals 0.1, so that means we have friction. So my force of friction. Notice that my vectors are not to scale. So just be aware of that. All right. In order to find my friction and all that good stuff to get my acceleration, I need to be able to determine what my normal force is. This is one of those things where I know in that y direction I'm in equilibrium. So the sum of my forces or my net force is equal to 0. The forces that I have acting in that direction are the normal force. And then I'm going to say the pulling force in the y direction, and then minus the mg. All right. So now we got to look at what the y direction component of this is. This is opposite my angle, and that's 100 newtons. So this would be 100 sine 30 degrees. So when I find the sum of my forces in the y direction, it's going to be normal plus 100 sine 30 minus mg. And in order to solve for the normal force, and that all equals, that all equals 0. This keeps switching to the eraser on me. Sorry about that, guys. So I want to isolate my normal force. That means I'm going to add mg to both sides. So this is going to go over to the other side, and it'll become a positive. This positive here is going to become a negative. So this is how it looks. I have normal force equals mg minus 100 sine of 30 degrees. All right, so let's go ahead and solve for that normal force. mg is going to be 15 kilograms. 15 kilograms times 10 meters per second squared minus 100 sine 30 equals 50. So this is really 150 newtons minus 50 newtons. And you probably don't need this many steps. I'm just showing you exactly how I'm getting the number. So 150 minus 50 is going to give me 100 newtons for my normal force, right? So notice that that is smaller than the weight of the object, which makes sense because you have a force that's pulling it upward. All right, so now that I have that normal force, I can go ahead and determine what my friction is. And remember, my force of friction is equal to mu times my normal force. So that's going to be 0.1 times 100 newtons. So my force of friction is going to equal a value of 10 newtons. All right, so now that we know that, this will be 10 newtons here, and I have the x component of this pulling force, which is going to end up being 100 cosine of 30 degrees, because that's the adjacent side. So let's go ahead and take a look at the forces in the x direction and get those resolved. So I have 100 cosine 30 degrees, and I have 10 newtons, which is my force of friction. Again, not to scale, folks. So the sum of my forces in the x direction is going to equal 100 cosine 30 minus 10 newtons, which is my force of friction. So that's going to be 86.6 newtons minus 10 newtons. So we have 76.6 newtons as my sum of the forces in the x direction. So you should have 76.6 newtons there. Then the last stage, I know that that net force, right, is going to equal to mass times acceleration. So if I'm looking for my acceleration, I put my finger over that, and it's my force divided by mass. So force over mass is equal to 76.6 excuse me, not meters, newtons, and then over my mass, which is 15 kilograms. 15 kilograms. So let me grab my 76.6 divided by 15 gives me 5.1 meters per second squared. So that would be my acceleration of the object.